The device shown here converts a longitudinal movement into a rotary movement. Its components include a small round sheet metal disc that is moved up and down via a wire attached to it, and a rotor consisting of a bent sheet metal strip with an axle passing through its center to hold it in position. Both components rest with their underside on the water surface. The transmission of the movement is based on an effect that is now presented in more detail here. For energetic reasons, liquids always strive to minimize the size of their surface area. The reason why, for example, two drops unite to form a larger drop is that its surface area is smaller than that of the two individual drops together. The possibility of saving surface area is also offered by a so-called meniscus, which forms on floating objects. As seen here, the water rises so high on a floating styrofoam ball that the surface of the water in its immediate vicinity is curved. In the present case, one speaks of a concave meniscus because the water surface is curved inwards. In order for the menisci of two styrofoam balls floating next to each other to unite into a shape that has a smaller surface area, they attract each other. Let us now consider the case of a floating thumbtack. In contrast to the previous case, the meniscus there is curved outwards, so that one speaks of a convex meniscus. In this case, too, there is a mutual attraction because the resulting union of the two menisci produces a shape that requires less surface area. When trying to bring a floating styrofoam ball close to a floating thumbtack, one experiences that they repel each other. Bringing oppositely curved menisci together results in a shape that requires more surface area than before. In summary, it can be said that objects with menisci curved in the same way attract each other and objects with menisci curved in the opposite way repel each other. Based on this rule, we can now explain the behavior of the capillary drive. If the disc of the drive is pulled upwards, a concave meniscus forms on it. When pressed into the water surface, on the other hand, a convex meniscus forms on it. Corresponding to the periodic up and down movement of the disc, this thus results in a continuous change between a concave and a convex meniscus. There are 4 menisci on the edge of the floating rotor. Where its two ends are above the level of the flat water surface, concave menisci form in each case. Its curved middle section, on the other hand, is below this level, which is why convex menisci form on it on both sides. In order to be able to follow the movement of the capillary drive better, from now on we will look at it in slow motion and freeze the movement in certain situations. In addition, the focus of the camera is shifted slightly downwards, which makes it possible to recognize the menisci by their visual effect. To make the process even easier to follow, the menisci are moreover stained according to their curvature. Red stands here for a concave and green for a convex meniscus. In the situation shown here, the disc and the side of the rotor turning towards it have menisci curved in the same way so that they attract each other. On the side turning away from the disc, however, the meniscus is curved in the opposite direction, so that this side is repelled. Overall, This causes forces to act on the rotor that support its rotation in order to reduce the distance between the attracted side and the disc. This gives the rotor so much momentum that it turns beyond the position where the distance is minimal. At this moment, the disc moves so that the curvature of its meniscus flips. The side of the rotor that was previously attracted is now repelled, while the side that is turning next towards the disc is already attracted. In order for the rotor to turn once around its axis, the meniscus of the disc must therefore flip 4 times at the right time.